1.3 Measuring Segments. In this lesson, we are going to talk about lengths of segments. We have our postulate here. This is the ruler postulate. And if you remember, postulates are accepted as fact. All right. The ruler postulate, and this one is named, so you can simply use its name if we need to justify, says that every point on a line can be paired with a real number. Now, this isn't anything special. It's very powerful, but it's not anything special. We are just making a number line. A line is an infinite number of points, and those points can be assigned numbers. And a point is a location, if you remember from last lesson. Point simply identifies a location, and we have now given it a value that we can all agree upon, all identify with. So the real number that corresponds to that point is called the coordinate of that point. And you have, in previous math classes, identified numbers on a number line, or in a coordinate plane, you have an XY coordinate. So nothing really new, but you now have a name for it. You have a reason for it. The ruler postulate allows us to measure lengths of segments. Okay, this is important. If we look at our line here, line AB, notice we have point A and point B. Point A is at value little a. We could put a number with that. And point B is at value little b. The distance, if we want to measure the distance between these 2 points, and distance means that we are discussing a length. Distance is length. The distance between these 2 points is the absolute value of the difference. Now, what does that mean? Absolute value, those are our upright bars here. Absolute value, if you remember, it turns everything positive. Absolute value is the distance from 0 on a number line. So whether you're going to 3 or -3, you are going the same distance. Positive just tells you that you are moving to the right, and negative just tells you you're moving to the left. So absolute value means we are traveling a distance, so it's always a positive value, and difference means we are subtracting. So if you notice here, we have a formula. This says the length of segment AB is equal to the absolute value of the value of A minus the value of B. This is read length AB. And if you look in your best friend, in your big packet, you have the reference page that tells you how to read mathematical symbols. And if you find AB here, notice this just says AB. There's no bar on the top of it with no arrows or anything. So this is length AB, which is very different from segment AB, ray AB, or line AB, which we learned about in the last lesson. All right, so important formula there. Let's look at a problem. If we want to measure a segment length, this reads, what is the length of ST? The length of segment ST. So first thing I'm going to do is identify S and identify T. So the coordinate of S is -4. The coordinate of T is 8. I am going to do the absolute value of the difference of those two, and I end up with 12 units. And we always label our units. If there's nothing there, you just call it units. If it's centimeters, you use centimeters. Now, what if we did length TS? What would that be? That would be the absolute value of 8 minus, it's always minus, and then -4. You have to be careful with those negatives. They are tricky. So this would give us TS. 8 minus a negative is always plus a positive, so that would be 12. And look, we get the absolute value of 12 is 12 units. So we are simply looking at how far do we travel on the number line. It does not matter which direction we go. So pause the video and do the example problem there. Do the problem. Okay, we were asked to find the length of UV and the length of SV. I identified my points. I put them into the formula. The 10 minus 14 in absolute value. Length of UV is 4 units. S is at -4, V is at 14. And so the length of SV turned out to be 18 units. Even if you put them into the equation in the opposite order, you would still get the same answer. All right, so this is a good way to find length. This is for horizontal and vertical lines. All right, our next postulate, one of my favorites, is the segment addition postulate. What do you suppose the segment addition postulate is going to do? I bet it's going to have something to do with the adding of segments. And this is the first in a family of addition postulates that we will run into. We have segment addition, angle addition, area addition. We have volume, but we don't actually have volume, but it works the same. We have a bunch of addition postulates that we will be seeing along the way. This is the first one. Okay, the segment addition postulate says that if 3 points, A, B, and C, are collinear, now remember that means that they are all on the same line. So we look here, we have points A, B, and C, and they are all on this line. And B is between A and C. So we need to have B in the middle. Then this formula is true. We should put that in red. Work with me here. All right. Let's do that. Okay. This says that the length of AB plus the length of BC equals the length of AC. Now let's look at this. AB, that piece right there, plus BC is equal to the length AC. All of our addition postulates are piece plus piece equals whole. And that is going to work for every addition postulate that we run into, whether it's area, length, angle, whatever. All right, so let's look at our next example problem here. This says that if the length of EG is 59, what are the lengths of EF and FG? So the first thing I'm going to do is label my diagram. I'm going to get rid of the red. I'm going to label my diagram because we draw and label on everything. EG measures 59 units. So that is the entire thing. And I know that piece plus piece equals whole. That's my segment addition postulate here. So I have my segment addition postulate. I substitute in my values. I do basic algebra, combine like terms, and I end up with x equals 6. Now we were asked, that's nice to know, but we were asked to find the length of EF and the length of FG. So what I'm going to do is substitute x back into my expressions for the length of those pieces, and we get EF is 34 units and FG is 25 units. And yes, we always label everything. I will count you off. Just because the book is lazy does not mean that we can be. All right, go ahead and pause the video and practice the segment addition postulate. Remember to label. Okay, that was fun. We were told that the length of JL is 120. We labeled that on our diagram. And then we said, oh, hey, we have two pieces of segments that go together to make one big segment. So segment addition postulate says the length of JK plus the length of KL equals the length of JL. And I substituted in. I did my math. I got x equals 9. Now I am asked to find the lengths of my two segments, so I substituted back in JK. The length of JK is 42 units and the length of KL is 78 units. Okay, that was fun. All right. Ooh, we got good stuff coming up here. Big red stars here. New ideas. When numerical expressions have the same value, we say they are equal. So, like when we were talking about absolute value, if I travel from 0 to 3, I have gone 3 units. If I travel from 0 to -3, I have still gone 3 units. Those segments are equal. They both have a length of 3 units. If two segments have the same length, then we say that those segments are congruent. And this is the word for the day, congruent. We are going to use this word more than you would ever think possible. So what this tells us is that equal length implies congruent segments. And vice versa. If your segments are congruent, they have equal lengths. If your segments have equal lengths, we can say they are congruent. Congruent is written as an equal sign with the similar line above it. This is the symbol for congruent. You definitely need to know, learn, love, and use this symbol. Additionally, you can mark the segments alike to show that they are congruent. And if you notice up here, this mark and this mark mean that those two segments have equal lengths. That is how we mark segments congruent. If you have more than one set of congruent segments, you use multiple marks. So let's say, for example, we have a couple of intersecting lines here, and I am going to put some points on them. I did not draw my lines very well. I need to erase that. Not that whole line, but that's all right. We'll go with it. All right. And some points. So let's do point A, B, point C here in the middle, D, and E. And I am going to say that these two segments are congruent. So I can say that segment AC is congruent to segment BC. Notice how I'm using proper notation. And I am also going to say that those are congruent. So segment CD is congruent to segment CE. Now, the purple segments are not congruent to the green segments. That is how we mark them differently. And if we had other lines, the next set of lines, we would use 3 tick marks and 4 tick marks and 5 tick marks. And then it starts to get a bit ridiculous. We can talk about that as we need to. Okay, so huge, 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 huge. This whole section here is huge, 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 huge. Congruence and proper notation, very important. All right. Next big, big, big idea here is midpoint. And you know what a midpoint is. Midpoint is halfway between two things, right? The midpoint of a segment is a point that divides the segment into 2 congruent segments. So as soon as we see the word midpoint, we know that our segment is cut in half. And we know that the 2 parts are congruent. So I see midpoint, and I immediately go to my diagram and mark my segments congruent. That is the first thing you are going to do. Midpoint, you go, oh, congruent. All right. A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect that segment. Bisect and midpoint are basically have the same result. If we say that line L bisects segment AC, this is line L bisects segment AC, I go and mark them congruent. Okay? If I know that point B is the midpoint of segment AC, I go and I mark them congruent. Midpoint and bisect. So midpoint or bisect, you see those 2 words? You are going to mark things congruent. Big, big, big ideas here. All right, let's see what this does for us. Let's look at our example here. Point Q is the midpoint of segment PR, and you need to read these like this. This is not Q is the midpoint of PR. This is point Q is the midpoint of segment PR, and we see that word right there. Midpoint jumps out at us. First thing we do is go over to our diagram. We find point Q, and we know that it is the midpoint of segment, and we find P and R. And the first thing that we are going to do is to say that those are congruent. And what does congruent tell us? Congruent segments have equal lengths. So we can say that the length, right, this means length, of PQ is equal to the length of QR. This is the definition of midpoint. And we will use this reason frequently. You see how all of these examples have had, you've probably seen this in your math books all along. You have the math part of it here, and then you're told what's happening. Definition of midpoint, substitute, subtract 5x from each side. This is what proofs are going to look like. Told you before, geometry gives you the reason why we're allowed to do the math. So we are using the definition of midpoint. We simply substitute in, solve for x, and then we are asked to find these three lengths. So we know that we find the length here, we simply substitute in for the length of PQ, and then we simply substitute in, find the length of QR, these are both in units, and then we know that the length of PR is those two added together, and we get 82 units. All right, go ahead and pause the video and do the last two questions there. Okay, that was fun. First question, is it necessary to substitute to find QR in order to find QR? And no, it is not, because we know that Q is the midpoint. By definition, we know those two pieces are congruent, and by definition of congruence, they have equal length. So definition of midpoint implies congruence. Definition of congruence implies equal length. So once we find one, we know the other one. All right, and we were given in the second problem here, U is the midpoint. As soon as I see the word midpoint, I mark them congruent. As soon as they are marked congruent, I know their lengths are equal. I substitute in, I get x equals 3. And then I simply substitute back into my expressions to find their lengths, which are 35 units, and the two of them add together to make 70. Now, I could have simply just found the length of TU. I would then know the length of UV because they are congruent, so they are equal lengths, and then I would just have to multiply by 2 to get the total length. So a lot of good stuff in this one. We had the way to find distance, our first addition postulate, segment addition postulate, and some really, really, really important definitions here, midpoint and bisect. And we will definitely talk more about this in class and for the remainder of the year. All right, have fun with the homework.